Make sure that you say why. You have to explain your answer on that one.
Because I got the others and they failed. I'm right because hopefully B, C, and D wrong.
So these are 10.2 notes. I have it written on there, but it's crazy small.
I'm actually going to put because
don't put that. Share my grades off.
So before we can talk about the tangent lines theorem, we need to talk about what a tangent line is. So up here, I want you to just circle this, and we're going to put the definition of that up there. And if you haven't picked up yet, we are starting notes. So, okay, so tangent line. It means that it only intersects one point. Can't spell today. Intersects. Sex at one point. So it only intersects at one point, which is kind of cool because it's basically like it just barely hits the circle. Yeah.
Wait, so is this on like the coordinate graph, or are you saying it just hits 1 point on the circle?
Only hits 1 point on the circle.
Okay.
Okay. So I'm going to show you. I'm going to draw it bad, and then I'm going to draw it good. So don't do this one here. So if I just, it's supposed to come in and just, oh my gosh, I hit 2 points. That's bad. You see how I hit 2 points? Can you see it?
Can it just go straight there and stop?
It doesn't stop. It goes through. It hits 1 point. Okay. So if I'm going to draw this perfectly, I'm going to go ahead and pick my point, and then I'm going to go ahead and just draw this. It only hits at 1 point. I'm sorry? So that is a tangent line. Calculus, half of calculus is the study of tangent lines. The first half of the year, you talk about tangent lines every single day, basically, whether you know it or not. Okay, so the theorem says that if you have a tangent line to a circle, okay, then if I draw my radius to that 1 point it hits, what do you notice? What do you guess?
90 degrees.
That this hits at 90 degrees. So the theorem says that the radius intersects the tangent line at 90 degrees. So what's the converse of that?
That it's 90 degrees on the other side. You can leave the radius there.
Okay. Yes. So basically, converse means just say that backwards. So let me change this. Let me sneak in. Let's sneak in if then. If you have a radius line, then it intersects the tangent line at 90 degrees. So I could say if tangent, really, then it intersects at 90 degrees. So to say that backwards, if radius intersects, oh my gosh, I cannot spell today. If radius intersects at 90 degrees, then it's a tangent line.
Oh, shoot. Not that far.
Now, the only thing I don't like about what I wrote, and this is McConnell talk, right? There's a very formal definition, is that I could intersect at 90 degrees but be here, right? That's obviously not tangent. But if it's coming here and that's 90 degrees, then it's tangent. Okay. So basically, if it looks like it's tangent, then we test to see if that's 90 degrees. So if I draw the picture of this, it's essentially the exact same picture, except I'm going, oh, this is hitting at 90 degrees. Therefore, it's tangent. And I want you to how many tangent lines does a circle have?
Infinitely.
Right. I could draw the tangent line in a bunch of different places.
Infinite.
Yeah.
It is.
The circle's gonna end at some point.
Because you
No,
never know
because you
how
can put
big
it
the
in
circle
the
is.
infinite amount of spots.
If
No,
you,
because there's an infinite
in
amount of
points,
small spots.
technically,
There's like
they got
infinite
no
amount of
space.
coordinates.
So,
Then you could put that you can
I am
cut it out.
No.
So if you drew a circle and you then try to create all the tangent lines, you would think that at some point you got them all. But then if you zoomed in, you'd be able to get the tangent lines in between the tangent lines that you didn't get.
remember when you made
Make sense? Like if you made it bigger. And then if you did all those, then you could zoom in even more. And then eventually you would be doing, okay, hit one molecule or one speck, right? And then the question is, can you cut that speck in half?
Yes.
Mathematically, yes, you can.
Yeah.
In real life, can you? No.
No.
Okay. So I think that's the debate you're having in your head. Okay. So is KJ tangent to P at J? So basically, it's asking what question?
If it's only one place.
If they're perpendicular.
If they're perpendicular. Basically, it's asking, is this 90 degrees? Okay. How can we figure out if that's 90 degrees? Pythagorean theorem. If the Pythagorean theorem works, then we know that that's 90 degrees. If you have a cell phone in your hand, throw it against the wall as hard as you can, please.
Okay.
Oh, mine's over there.
Thank you.
Why do that?
Yeah.
Did you actually do it?
Okay.
They're not. They're
So basically, to figure out if this is a right triangle or a right angle, we're going to do the Pythagorean theorem. So it's hypotenuse is what length? 10 squared. Does that equal 9 squared plus 6 squared?
No.
That's a 9.
100 equals,
That's a 6. Which
10 plus 4.
Oh, okay, I see that.
yeah, this length here is 10.
100 does not equal 100.
81 plus 36. 117, is that what you said?
Yeah. And then 100
Does not equal, so what do we say?
No.
No.
Not. Not tangent. So, and I like that she said that it's acute. We learned it's all about the hypotenuse. If the hypotenuse is small, then that triangle is actually acute. Okay? So I shouldn't have written that 90 degrees on there because that's not right.
Is there another way to solve that?
I don't think so.
Is there, so is it basically saying that it hits at 2 points then? Is that
Yes.
what we do?
Technically, it's either going to, if we zoomed way in and actually made this, it would hit either at 0 points or at 2 points. Yeah. If it hit at 1, then it hit a second.
Wait,
Zooming way in.
if you can keep going and once you touch more than 1 point at once.
Not a true tangent line.
But then a true tangent line doesn't make sense.
Because there's
We-
points inside
With our
points.
pencils, could we ever make a true tangent line?
No. It's too thick.
You would need like.
Yeah.
Like, why are we learning about things that
Stop.
don't even exist?
Okay.
That is a great question.
Because math is awesome. Okay. So segment ST is tangent. So basically they're telling us that it's what? A right triangle. So really saying something's tangent for this class is saying that it's a 90-degree angle to the radius. To the tangent to the R, the center of R is, the center of the circle is R. What is the radius of R? So what is this length here?
15.87450787.
How'd you get that?
I did math.
Okay, I'm listening.
So you did, you go 24 squared?
Okay.
No, yeah.
I did 24 squared minus 18 squared and the square root of the answer.
But it's 18 plus x squared.
Correct.
You can't just do 18 squared.
Oh.
So I would say, what is the hypotenuse?
24.
No.
Squared.
Yeah, 18.
18 plus
It would be 18 plus x.
The hypotenuse is this whole length right here.
Oh, yeah.
So it is 18 plus x squared
Is this how the other stuff comes in? Why is
equals, not really,
Because I had a theorem mark.
x squared
Oh.
plus 24 squared.
And then algebra.
And then algebra,
2 squared divided by.
careful. Biggest mistake I ever see is someone says square this, square that. What do we actually have to do? Starts with an F. Foil. We actually have to foil this. Whether you write it twice or not, okay, I can foil without writing it twice. Some people need to see the visualization.
X squared plus something x plus 36x plus 18 squared.
What is 18 squared is, okay, so 324. And then plus 18x plus 18x plus x squared. If you could have done that quicker, awesome sauce. The nice thing about these, is that it's that we have the x squared on both sides. If we didn't have that second x squared, do you know how you have to solve this? You have to use the quadratic formula. Okay. But these x squareds do what to each other? Cancel out. 24 squared is 576. So 324 plus 36x equals 576. Subtract. Turned it into an algebra 1 problem. Divide by 36. X equals 7. The radius equals 7. I get really confused when I looked at the homework because a lot of times they didn't give me this value. And they did on this sample. Why do they not have to give me that value?
Because the radius is the same no matter where it's at.
Because the radius is the same. So if I give you one radius, any other radius is also x. Or down here, if they didn't have to give me this value, okay? And they don't in the homework, but they do on the sample problems. So on the homework, they don't give me this number.
So basically, we just solve for what x is on the hypotenuse, but since it's this.
It's the same x, right?
Yeah, we're not done yet. No, we are not done yet.
All it asks is for the radius.
Yeah, if it asked for the hypotenuse, we wouldn't be done, but it didn't. Okay. Next problem, solve for x. And now they're talking about angles. I didn't write this on here, but it's a tangent line. Okay, M and N is a tangent line. As soon as I say tangent line, that means what?
What's the tangent?
90 degrees. M and N are tangent lines. Yeah.
I think I know how to do this.
Okay, I'm listening.
Okay, so draw a line from B to C.
Okay, I don't want to, but okay.
Okay, so then you have the same distance from B to C and C to C because it's a radius.
That's not a radius.
They're not? No.
B to C, I have to go.
B, T, and D and C are radii.
Yeah.
So they're the same.
So you want me to say that this is congruent to that?
Yes.
Okay.
So then you can find those two angles, and then you can use that to find the other triangle.
But let me ask you this question. What is this angle right here?
I'll have to answer that once we have the other solved.
We know that it's 90. If I tell you this is a tangent line, I'm basically telling you that that's 90 degrees.
Then it's 45.
And then what is this?
90.
It's also 90.
So
And we have a what kind of shape there?
it's a four-sided
Quadrilateral.
shape, so n minus 4 times 45, n minus 2 times 180.
Is 360. So 360 degrees equals x plus 90 plus 90 plus 135. 45?
Could my way of work though?
I don't know.
Okay. Then I want to try it.
Okay, after notes.
Okay.
Oh.
And then show me, and if you show me, I might give you some extra credit.
Oh, wait, I remember.
Is MP tangent to N? So they're saying, is this line here tangent? They're really asking what question?
What's the final angle? What's that other angle?
They're asking, what's this angle? Basically, they're saying, is that angle 90 degrees? What is it?
89.
That angle is 89 degrees. So the answer is no, because angle NMP equals 89 degrees. And I could say yes, because that angle equaled 90 if it had. Tangent line is basically just saying 90 degrees.
What?
If LK is tangent, boom, that is a tangent line. What is the length of KN? So they want to know this length. This is this example of where at first I go, I need to know this length in order to do this.
You have it already.
What is it?
It's 9.
It's 9. They already kind of, any radius is always going to be the same as the other radius. That's 9. So help me out here.
So it's 9 squared plus parentheses x plus 5 squared is equal to parentheses x plus 8 squared.
Wait, can't we just?
Because the minus 1.
I
Good.
did a D instead of an I.
How does that look like?
Why did he say 8?
Because minus 1 and 6.
Okay, because this is x minus 1. We got to combine these to get my hypotenuse.
Can't we just add 5 to 9? Why can't we do that?
Here?
Yeah.
Well, because order of operations says do what first? Mm-hmm.
But why did? Oh, we added that because.
So 9 squared is plus. Can you FOIL this? What is it? Without writing it down, or do you like writing it?
X squared.
X equals 7.
Plus 25.
X equals 7.
And the other side?
X squared plus 16x plus 64.
Okay, our x's cancel. In Algebra 1, they really push for us to do keep everything positive we can. So that means what side would my x be on?
Right.
Right? So I think I get 6x. X squareds cancel. Took care of that. Took care of that. What do I get on my left side? 39.
Wait.
42.
81 plus 25 minus 64.
42.
Can you be nice to the numbers?
It's 42.
That's not, I don't like, try again.
The number on the left side is 42.
Better.
What do you want him to say?
Please write number 42, my friend, on the left side.
No, it still has attitude in it.
My dear friend on the left side of the equal sign.
Oh, wow, I found it. It's 42 on the left. Isn't that awesome? The difference.
Oh my God.
Some of my best friends are numbers, so be nice to them. X equals 7. Did we answer the question? I think not.
I don't think not. Your ones are also made up. There's
I know.
6. X is 6. Non-existent.
No.
Most of my friends are imaginary numbers.
No, you know what
So
it's 15. 1 plus 9. 15.
That's what I really should have circled.
I did that. Sorry, that made me excited.
See, because you love the numbers, don't you?
Yes.
You're not like, write 15. Write it. It's 15. Write it. 15. Write 15.
Is that really what Brody sounds like?
Hey, let's go to tennis and let's go to a tennis match and play. And listen to them yell 15.
My wife, when she does my voice, when she impersonates me, it's always, I've got to take out the trash. I want to watch the rest of the show. I really like the show, but then I will do the dishes, but let me take out. That's how I talk, according to my wife. Yeah.
How did the problem we just did, we were doing like the 9 squared plus x plus 5 squared equals x squared. How did we get that?
Which part? So that's Pythagorean theorem. That's a squared plus b squared equals c squared. Wait 1 second, please. So this was our A.
Oh wait, never mind. Okay, I forgot that the thing with this side right
We're not doing anything else.
Keep going. I was like wondering why we were doing that.
Mark?
Why can't we turn all like the tables like this and make like 2 tables so like you don't have to turn around and have chairs?
You can sit wherever you want.
But like
I don't care. You can turn tables, just put them back.
But why do they have to separate it?
All right, so I did Hope did yeah, I think I got a detention stuck in my throat. I got a detention stuck in my throat. Trying to figure out what it says. Okay, so I liked Hope's idea on the last problem, though it felt like she went a little bit on a tangent.
oh, that's really
I hate you.
That's so funny.
I hate you.
I don't see it.
Why do you do this to me?
Yeah, I don't get the joke.
I already have to deal with Maddox. Now you, Maddox, what have you done?
I actually would like to discuss why that word means what it means. So tangent means to kind of go off. Okay, I'm talking about one thing, and you intersect my conversation with one thought, and then take it somewhere completely different.
Yeah, like one day we were talking about
Oh, we go on tangent all the time in class.
One day we were taking a test. Tangents are a great.
yes,
Literally.
literacy.
All right, so I am not going to go on a tangent.
Yes, I did. I hate you.
So Hope's idea was to start showing that things are congruent. Really, the big lesson about tangent lines is that it's basically creating a 90-degree angle. But also, this theorem says that, yeah, this and this are going to be congruent, those segments. Well, we kind of already knew that because they're the radius. All radius in the same circle are congruent. Okay? All radii. Okay. But this also goes on to say that this side is congruent to this side. Now, that is a good question of why, and I debated for half a second to make you prove this, but I decided not to because I don't think we need to. But if I were to draw this segment, okay, which I know is congruent to itself, and I already know that this is congruent to this side, I can't do angle side side, but that is by HL, I can say that these two triangles are congruent, therefore this side is congruent to that side. Okay. So
Give me 1 second to start Thank you.
Hey, I will.
You should get a swimming
Mine had
coach
the most.
because I'm the geometry teacher.
Mine had
yeah.
Yeah, my swim coaches have it. They always point to the shirt. I'm like, I was speaking to
So I want you to visual, guys. I don't know why you think you can talk over me. So I want you to visualize, and sometimes this gets confusing on the next problem. It's not that hard, okay? But basically, what shape does that create with those 4 sides? It's a kite, okay? Now, it gets really confusing when they have 4 kites that are similar, but if you have a circle, we're basically looking for this shape out of it. So what gets awful is sometimes they make kites, and I can make some kites that are very, very similar. I'm sorry. Make some kites that are very, very similar. And then, oh, I drew that bad. Okay, so if you make kites that are real similar and close together, it makes it hard to kind of see what goes with what. That's not a very good example. I apologize. But my point is, when I look at this shape, I know basically things are congruent. I almost want you to draw the kites. How many kites do we have here?
4.
4. We have 4 kites. There's one of them. There's the second.
So make sure you have all your shape properties.
Okay, so you can kind of see these. And what happens is we know that kites, they're congruent on the part that's sticking out. Okay, so that means this length right here is 2. That means this length right here is 7. If you visually can't see those kites, okay, you're going to have a hard time doing these problems. This length here is 6. And this length here is 3. So now when it says, what's the perimeter of this thing, all I got to do is, what is it?
36.
Right? 36. Okay, so the perimeter. Oh, I found it. It's 36. Okay, how did she find that? She just added all those numbers up. Okay, so visually, if you can't see those kites kind of cut up in there, it's tricky. I recommend, and this one isn't as bad as they can get when you get kites that are all basically the same. I wish I could find that one example I saw in the homework. Let me find it real quick.
I thought that was going to be a dreadful problem for them.
Next time, yeah, I don't see one.
Why isn't there
So basically, they just try to kind of, I'm going to just show you this one. So how many kites do you see in this picture? There are 3 kites. I only count 3. But if you can see, can you look at the board, please? If you can see those 3 kites, then life's kind of good, and take your time and realize if you know one of these, if I know A, B, it tells me other lengths and so forth. Okay? I'm sorry? Yeah, so they're going to visually try to kind of mess with us. Oh, I think it was on the homework. Right, so like this one, maybe it gets a little confusing of which kite is which. So take your time. They didn't even draw the kite, so I would probably add in this radius and draw the kites. That might make life a little bit easier. Okay?
Oh, so you have to like connect the diagonals and make the kites?
I think visually, I think it's easier if you do it that way. You don't have to. If you just answer the question and it's right, life's good. But I think visually to have those kites in there makes it a little easier.